Section 9.1 Polar Coordinates. So far we've learned what we call rectangular coordinates. Rectangular coordinates deals with the XY plane. The XY plane that we have been seeing since fourth grade. You plot points, graph straight lines, find areas, equations. Here we introduce a new system. It's called the polar coordinate system. And what is this for? This is just to help in some areas in mathematics. It has more advantages and it helps more us to solve problems using polar coordinates than rectangular coordinates. So in the polar coordinates, there's instead of the origin, there's a pole like this here, and then there's this is called polar axis. So this coincides with the x-axis. So if we draw the rectangular plane, xy plane, this is the pole here, and this is the polar axis. This is the polar axis. So the polar axis, this one is basically a ray that goes from the pole out. It's a ray. But that coincides with the positive x-axis. So the question is, as we learned back in rectangulars, the first thing is we learn how to plot points in the polar coordinate system. So let's start with let's say we need to plot 4 comma pi over 3. Okay, what is that? This is all the xy points that we learned back in rectangular. They have equivalent to r comma theta in polar. R comma theta, and we'll see what r and theta are. So let's look back at the first figure we drew. So if you draw any ray, if we draw any ray here, this is theta, is the angle that makes with either we say the positive x-axis or with the polar axis. And r, it tells us how far from the pole is. So I'm going to just call it origin for now. So let's say r is 2, so then that would be the point there. So r is on this line here, on this ray that I just drew. Theta can be negative, r can be negative. What about if r is negative, then it goes in the opposite direction. So you travel in the opposite direction, opposite value of r distance. So if it's negative 2, you go this way. Then the point would be located at that one. So let's look at specific examples. For this one, pi over 3 and 4. So we draw angle pi over 3, that's pi over 3. And 4. So 4 means it's going to go 1, 2, 3, 4. Because it's a positive, so that's where the point is located, 4 pi over 3. So any axis we draw, the ray that we draw first, that's always the positive ray, I call it. Now let's look at another example. Plot 2 comma negative pi over 6. 2 comma negative pi over 6. How do we plot something like this? Well, first we start with the angle first. It's negative pi over 6, so it's down this way. Negative pi over 6. And then now this is the positive ray. Whatever I draw the first ray, that's my positive ray. So the 2 is positive, so I'm going to go 2 units on that. So that would be the point. 2 comma negative pi over 6. Another one, plot the point 2 comma 0. 0 means 0 degrees or 0 radians. So it's always r comma theta. So how are we going to plot this? So it's a 0 degree. This is the 0 degree angle. It's the same as the polar axis. And then you go on that 2 units. So it's here, 2 comma 0. What about if we change r into negative? And then keep this positive for now. And then we make it degrees. It's the same thing if it's degrees or radians. So here we start with theta, 120, that's 120. But it's a negative 3. So you don't go on the positive ray, you're going to go in the opposite direction. 1, 2, and 3. So that's the point, negative 3 comma 120 degrees. The next one, let's say we're asked to plot -4, -pi. So negative pi, this is negative pi. Or you go this direction, you can land at the same axis. It's negative pi. So this means this is my positive ray. This is the positive ray. But they want negative 4, so you're going to go in the opposite direction. So you're going to go this way. 1, 2, 3, 4. So that would be the point. That's how we plot points in the polar coordinates. What about if we're asked to plot 4 comma pi over 3? And then what I'm going to do with this, I'm going to add pi over 2 to it. 2 pi to it. So that would be 4 comma 7 pi over 3. And I'm going to look at the case when I subtract 2 pi from it. That would be 4 comma negative 5 pi over 3. So we get 3 points to plot on the same axis, same polar axis. So we have 4 pi over 3. Pi over 3 is 60. And then you go 1, 2, 3, 4. That's the first point. 4 comma pi over 3. Now, where is 7 pi over 4? So remember, when we grab, I want to sketch or plot this 7 pi over 4. 7 pi over 4, you go pi over 3 and another 2 pi. So it's going to land you at the same axis. And then you go up 4, 1, 2, 3, 4. Oh, it landed at the same point. What about the other one? The other one is you go pi over 3, as you notice, pi over 3, and then 2 pi in the opposite direction. It landed us at the same point. So all of them, all these points are the same on the polar axis. They're all the same. They land at the same point. So if you travel 2 pi more, 4 pi more, multiple of 2 pi, could be positive or negative, it lands you back at the same point. So that's how we get the same point all the time. Now we move on into conversion. How do we convert conversions between the points? Between, if you are given x, y, how do you get it back to r theta, and vice versa, and vice versa. So if we look in here in the plane and pick a point r comma theta, drop a height, this is the x and that's the y distance, this is the r distance, or you can say absolute value of r. So this is theta. If I find sine theta, that gives me opposite over the hypotenuse, and cosine theta, adjacent over the hypotenuse. So from here we get y equals r sine theta and x equals r cosine theta. X equals r cosine theta. These are important to know. So to do conversion from a point rectangular to polar and vice versa, we use that. Also, let's keep in mind we can do more stuff here. So we said x equals r cosine theta, y equals r sine theta. Also, we have x squared plus y squared equals r squared by the Pythagorean theorem. And not only that, also theta is tan inverse. So if you find tangent theta is the opposite over the hypotenuse. So theta is tan inverse of y over x. So that's also important. These are the only 4 relations that connects rectangular to polar. So let's say we are given 4 comma pi over 4 and we would like to convert this into rectangular. What would that be? Well, remember x is r cosine theta. R here is 4. Cosine theta is pi over 4. This is 4 times root 2 over 2. 2 square root of 2. For the y is r sine theta. R is 4. Sine theta is pi over 4. That gives us 4 times square root of 2 over 2. So the answer is 2 square root of 2. So this means that point 4 comma pi over 4 is the same as 2 square root of 2 comma 2 square root of 2. if we take another point, -2, negative pi over 3, how do we convert that into rectangular xy? To do so, again, x is r cosine theta. R here is -2 cosine. Theta is negative pi over 3. And we know from even odd identities, cosine negative alpha is simply cosine alpha. So we can drop the negative. And cosine pi over 3 is 60 degrees. Its cosine is 1/2. So that gives us -1. For the y, r sine theta. R -2 sine negative pi over 3. Again, from even odd identities, sine negative alpha is negative sine alpha. So it becomes positive. 2 times, this is √3 over 2. These cancel, so you get square root of 3. So this means -2 negative pi over 3, this point becomes -1 square root of 3. So that's how we convert from polar to rectangular. What about backwards? If I'm given 0, 4 and I'm asked to convert this into r theta. So 0, 4, this means this is x, this is y. I need to find r and theta. So remember how we have r, or r square is the square root of x squared plus y squared. That's r. So r equals the square root of 0 squared plus 4 squared, which is 16, and that turns out to be 4. And theta, we told you theta is tan inverse of y over x. Tan inverse of 4 over 0. So tan inverse of undefined. What's the angle? It's tangent undefined is pi over 2, which is 90 degrees. So then 0, 4 becomes 4 comma pi over 2. And always we need to test that out by plotting the point 0, 4. This is 0, 4. Does it make sense? It's 4 pi over 2. Let's see. We start with pi over 2. That's pi over 2. And we go up 4 units. 1, 2, 3, 4. Yes, so it's correct. Let's look at another example. -2, 2. We would like to convert this to r comma theta. How do you convert that to r comma theta here? So here, this is the x and this is the y. Again, r is the square root of x squared plus y squared. R equals x is -2 squared, y is 2 squared. So r equals the square root of 4 plus 4, which is the square root of 8. And that's 4 times 2, or 2 square root of 2. This is r. Theta is tangent inverse of y over x. Tangent inverse of -1. So now what's the angle? Is tangent -1. So first you can plot that point -2 and 2. So it's going to be here. This is theta. So what is theta? It's not negative pi over 4 though. Some people might put negative pi over 4 because there's a negative there. So if you drop the negative, it's really pi over 4. So if you put negative pi over 4, which goes this way, all you have to do, add pi to it. That gives us 3 pi over 4. So then the point we're looking for is always r comma theta. So 2√2 comma 3 pi over 4. Another example. Let's say we have the square root of 3 comma 1. We need to get to r comma theta. So let's see what we have. This is always x and y. Okay, so we need to find r. R is defined as the square root of x squared plus y squared. And what do we have in here? X is the square root of 3 squared and y is 1. That gives us 3 plus 1, which is 4, and that simplifies down to r equals 2. Theta, at the same time now, theta is tangent inverse of y over x. Tan inverse, y is 1, x is √3. So now what is the angle? So if you plot that point, √3, maybe here, and 1. So that's the angle here. So what's the angle? Its tangent is 1 over square root of 3. That would be the one with sine 1/2 and cosine root 3 over 2. And that would be 30 degrees or pi over 6 radians. So that's theta. So that point becomes 2 comma pi over 6. Next one, how do we transform an equation? It could be polar or rectangular, either way, from polar, I'm gonna put an R like this, to rectangular. Well, let's look at an example. Let's say R equals 5 sine theta. How do we convert this to rectangular? Well, here there's a trick, one trick. You multiply both sides by R, so you get 5R sine theta. R squared is x squared plus y squared. R sine theta is y. So that gives me the equation. R sine theta is y. What about another one? But let's say 2xy is 7, from rectangular to polar. Well, as long as you get rid of x and y, that's what matters. So x is r cosine theta and y is r sine theta equals 7. We can multiply this out to get 2r squared sine theta cosine theta equals 7. You can leave it like this, or if you like, you can group the 2 sine theta cosine theta together, as you can see. And then this is sine 2 theta, double angle formula for sine. So that gives me kind of like simplified version of it. Another example, what about r squared equals sine theta? Well, again, multiply by r, you get r cubed equals r sine theta. So this is basically r squared times r, if you like to write it, r squared times r. This is x squared plus y squared. And r is the square root of x squared plus y squared. And the one on the right side is y. You can leave it like this, that's fine. There's no more r or theta, there's only x and y. Or you can rewrite this x squared plus y squared. This is to the 1/2 plus 1 3/2 equals y. That would be the more simplified version of the answer. What about if we have r equals 2 cosine theta minus 3 sine theta? Again, if there's no squares or anything like that, so the key here is to know x is r cosine, y is r sine. So here missing is r, so multiply everything by r. So 2r cosine theta minus 3r sine theta. R squared is x squared plus y squared. 2r cosine theta, what's r cosine theta? It's x. R sine theta is y. And you can leave it like this. No more r or theta. What about one last example? R equals 5. Here we're not going to multiply both sides by r because there's no sine or cosine. So instead what we're going to do is we are going to square both sides. So this is r squared is 25. Why did I do that? Because this one is x squared plus y squared is 25. Notice how you get, it's a circle, center 0 0, radius 5. That's what this section is about. It's an introduction to polar coordinates, how to plot points, and how to convert from polar to rectangular and vice versa.